Problem 5.4.2. Let's write what we know and what we need to find. So for part A, we know that the mass is 70 kilograms. And we want to find the weight on Earth. Since they said on Earth, I can immediately say that the acceleration of gravity, or g, is negative 9.8 meters per second squared. I know that w, the weight, is equal to the mass multiplied by the acceleration of gravity. So I substitute. W is equal to 70 multiplied by, by negative 9.8. I use my calculator to find the answer, and I find it to be negative 686 newtons. Or I can say that the weight is 686 newtons downwards. In your book, the book is accepting answers as 686 newtons without the negative sign. Pay attention to that. Now, B. How much would she weigh on the moon? So she, we're talking about the same person. Mass does not change because the mass is constant wherever we go. We still want the weight, but now we have the gravity of the moon, and they told us that it's 0.166 g on Earth. So first we find the gravity on the moon. Multiplied by negative 9.8, and the answer will be 1.63, of course negative. So negative 1.63 meters per second square. And now I can substitute. So 70 multiplied by negative 1.63, the answer is 114 newtons, or the weight on the moon is 114 newtons downwards. And again, your book is accepting the positive answers too. C, they ask us to find the weight on neutron star, where the gravity of the star is huge, 1.43 times 10 raised to the power of 11, the gravity on Earth. So the gravity of the star is 1.43 times 10 raised to the power of 11, the gravity on Earth. The mass didn't change, and we still want to find the weight. I apply the same concept. This is exactly the same as B. Only numbers are different here. And the answer is 14.0 times 10 raised to the power of 11. Or if I want to write it properly in scientific notation, it will be 1.40 times 10 raised to the power of 12. Now I substitute. And I multiply. Now if I want to write this number again properly in scientific notation, will be 9.8 times 10 raised to the power of 13 newtons, where the weight is 9.8 times 10 raised to the power of 13 newtons downwards.